In this video, we're going to be looking at the profit, revenue, and cost functions. Revenue, this is the amount of money a company receives from the sale of a product or services. For instance, if you go to a store and you buy 10 candy bars for $2 a piece, then you have to purchase them for $20, and that $20 is the revenue that the store gets from selling you those candy bars. Cost, this is the amount of money that we need to manufacture a product. There's two types of costs. One is the fixed cost and one is the variable cost. Fixed costs are ones that you incur even when no products or services are produced. Variable costs are ones that depend on the number of units or the amount of services produced. Fixed costs are always just a number. Variable costs always include a variable. Lastly, we've got our profit function. This is the amount of the money a company will net from the sale of a product or service. Next, let's look at a few formulas. Revenue is equal to the price times the quantity. So when we're talking about price, we're talking about the amount of money a company will charge for a product. So for instance, if we think about those candy bars, the price was $2. Quantity, this is the number of units that are produced, the number of units that are sold. So if we're making a formula, we usually use P for price and Q for quantity. Sometimes we use X for quantity, but P times Q is always our revenue. A cost function we can think of as those variable cost plus our fixed costs. And in this video, we're going to be looking at just linear cost functions. So if we have a linear cost, our cost is going to look like C equals mx plus b. And we can break this down into those two parts, the variable cost and the fixed cost. The variable cost, that's our mx. The fixed cost, that's our b here, our y-intercept of our cost function. And I also want to look at our slope. So when we have a linear cost, we've got a constant slope, and we refer to this as our marginal cost. Marginal cost is the cost to produce one more unit, and when we've got a linear function, that slope is the marginal cost, and it's the cost per unit. Finally, we've got our profit function. Profit is always revenue minus cost, so you can take this revenue function and subtract the cost function to build your profit. Let's look at a specific example. So in this example, we are given that the cost to produce X bottles of hot sauce in a month is given by C of X equals 3.40X plus 428. And the units here, I forgot to put, but we're going to say dollars. Each bottle of hot sauce is sold for $8. The first thing we're supposed to do is identify the fixed, variable, and marginal costs. So remember our fixed costs. When we look at our formula for our cost function, this is the part that's just the number. So our fixed costs here are $428. Our variable cost, this is the part of our cost function that includes the variable. So this term here is our variable cost. So we have 3.40x. And the last thing they want us to find is the marginal cost. And remember, our marginal cost is the slope of our cost function. And our slope here is 3.40. And the units, remember, this is the cost per unit. So it's going to be dollars per bottle of hot sauce. Next, they're asking us to find the cost to produce 100 bottles of hot sauce. And then a similar question that says, find the cost to produce the 100th bottle of hot sauce. Now, when we look at this, there's very little difference in the language there. But this first question is asking us to find the total cost of all the first 100 bottles. So we're adding up all those costs together. And in the second question, what we're doing is we're isolating just the 100th bottle. In the first question, what they're asking us to do is find C of 100. So we're going to take that 100 and plug it into our cost function. So we're going to end up with 340 plus 428. So this is $768. In the second question, they're really just asking us for our slope. The cost of the 100th bottle is the cost of the 1000th bottle, and it's going to be the same as the cost of the 50th bottle. The cost of each bottle of hot sauce is $3.40. Next, we're asked to build the revenue and profit functions. So remember, our revenue always equals our price times our quantity. And they tell us that the price for each bottle is $8. So our revenue is going to be 8. And we're using X for our quantity instead of Q. So R of X equals 8X. Or you could write R equals 8X, either way. Our profit is always our revenue minus our cost. So our P of X function is going to be 8X minus that cost function. Since our cost function up here has two terms, I need to put it in parentheses so that I make sure I subtract both terms of my cost function. Now when I go to simplify here, this negative sign has to be distributed across both terms. So my profit function is going to be 8x minus 3.40x minus 428, and I get P of x equals 8 minus 3.4 is 4.60x minus 428. Next, they're asking us to graph each function. So it's often helpful to build a table of values when you go to graph. So I'm going to pause my video and build that table. I've built 3 tables, one for each function. Notice that I've put the same x values in each table. That's just going to make it a little bit easier for us to see what's going on. And if I look at my functions, let's graph my revenue function first. I'm going to graph my revenue in red. So my revenue function, it looks like we're going from 0 up to 1200. So let's make each tick mark here be 200. So this is going to be 1200. This is going to be 400. So putting in a few values, let's make tick marks on my x-axis also. So at 50, we're up here at 400. At 100, we're at 800. At 150, we're up at 1200. So my revenue function is going up like this. I'll do my cost in blue. So my cost function starts out at 428, so it starts about here. Next one is 598, so almost at 600. At 100, we're at 768, so that looks like it's about here. And at 150, we are at 938. That looks like it's about here. So we've got a function that looks sort of like this. Our profit function, let's graph this in green. Our profit starts down here at negative 498. So it starts down here. At 50, we're at negative 198, so that's about here. At 100, we're at 32, that's about here. And at 150, we're at 262. So that looks about like this. Now, when we look at these graphs, notice when our revenue is above our cost function, our profit function is going to be above 0. So in here, over here, we have a profit. Whereas over here, our cost is above our revenue, which means our profit is less than 0. So over here, we've got a loss. This point right here and that point right there, Those are referred to as the break-even point. Let's find out where that break-even point is. Let's find out where that break-even point is. Our graph had a break-even point. Here, let's draw that graph. So basically, that's my revenue. My cost was like this, and my profit was like this. So that break-even point occurred right here and right there. It's just one spot, but we can find it two different ways. The break-even point can be found by setting your revenue equals your cost, or it can be found by setting your profit equals 0. Let's do it both ways. So our revenue function was 8x. We're setting this equal to 3.40x plus 428. If I subtract 3.40x from both sides, I get 4.60x equals 428. And then I just need to divide both sides by 4.60. And I get x equals 93.04 about. If I did the same thing with the profit function, I would have 4.60x minus 428 equals 0. So if I move this over to this side, I'd get 4.60x equals 428. Divide by 4.060, and I get that same value of x. So what this tells us is, in order to break even, in order to not make any profit or have any loss, I have to produce 93.04 bottles. Now, the thing that's difficult is that makes no sense, because we can't actually make 93.04 bottles, because you can't make 0.04 of a bottle. So oftentimes what we do is, instead of reporting the break-even point, if it doesn't fall at a nice even number, what we do is we figure out what is the smallest number of bottles that must be sold in order to make a profit. So when we look at our graph here, this is where we have 93.04. And when we see a number like that, we typically will round down to 93 bottles. However, if I round down to 93 bottles, I'm over in this region, and that's a loss. There's a loss, a very small loss, but a loss. And we want to make a profit. So instead of rounding down like we normally do with a 93 number like 93.04, what we're going to do, not going to do this, we're going to round up to the next whole. So in order to make a profit, the smallest number that we can produce is 94 bottles. That's it for this video. Thanks for watching.